function composition. Let's take a function that we're going to define as f of x. We know a function will take in an input and produce an output. But let's say after it produces this output, we want to chain this function f of x to another function which we will call g, to where that output from f is now serving as the input to g. So let's call this the output for f, but it doubles as the input to g. Then that produces a new output. And the act of chaining these functions together is what we call function composition. And there's nothing stopping us from chaining together more than two functions. So we could take the output from g, and that could become the input for a new function h. And that could chain into another function if we want. And there's also nothing stopping us from chaining the same function together more than once. So it could go from f to g and then back through g again. Okay? So this act of chaining together functions produces this new operation, and we're going to call that function composition. Now the notation will look like the following. We started with some input x, and we input it to some function f. That output, which can be represented by f of x, was then input to the function g. And then in this case, that new output, which we'll call g of f of x, was then input to h. So with this notation, understanding that chaining of events, when we started with x, then that produced f of x, and then that was plugged into g, and then h, we can see that we're going to work inside out to evaluate function composition. And the way this reads for this specific example is h of g of f of x. So we're just peeling back layer by layer as we chain together these functions. Now some alternative notation would look like the following. Let's say that we have composition that looks like g or f of g of x. You could also see this notation, which means the same thing. F open circle g of x, or let's say we had g of f of x. That would look like g open circle f of x. Or if we had g of x, again, we can chain one function to itself. If we would like g of x. So alternate notations mean the same thing. We are taking one function and composing it into another. Essentially, we're taking that function and plugging it in to another function. So start with an input, run it through a chain of functions to produce some new output. So let's look at some examples. We have two functions, f and g. F, a linear function, 3x plus 1, and g, a radical function, 2 squared of x minus 2. The first problem, it says, find f of g of 2. So the input is 2. And knowing that we're going to work inside out, we're going to run 2 through the function g, and then that new output we will run through the function f to produce the final result. So first, we have to find g of 2. So g of 2 will be found by replacing x with 2. So x represents our input variable, and now the input is 2. 2 minus 2 is 0, square root of 0 is 0, 2 times 0 is 0. So g of 2 is 0. So this becomes f, and now we know what g of 2 is, so we're going to evaluate f of 0. F of 0, when I plug in 0 for f, we get 3 times 0 plus 1, which is 1. So running through the input value of 2 through the chaining of functions g and then f produces this new output value of 1. Let's look at part B. Now instead of running through the order of g then f, we're going to run through f and then g. So let's first find f of 2. F of 2 is going to be 6 plus 1, which is 7. So the g of 7, we plug in over there. We're going to get 7 minus 2 is 5. Square root of 5 will leave us square root of 5, so 2 radical 5. So square root of 5 can't be simplified anymore. So there is our answer for the second part. Next, it says find c if, when running through c through the chaining of functions or the composition, first through G, then through F, it gives us 25. So now we know what the output's going to be after the chaining of G and F, or the composition of G into F. So let's figure out what value of C would make that happen. So here's what we can say. Well, what is G of C? So G of C is going to be 2 square root of C minus 2. So we don't have a numeric value for this, but we'll leave it as this expression. So then we want to find out, well, what is F of that thing? So 2 radical C minus 2. So we have to plug this into F. And we're going to get 3 radical 2 C minus, or 2 radical C minus 2 plus 1. Now here's what we know. This thing is going to equal 25. So we have to figure out what C value will make that happen. So we have an equation that we can now solve. So let's subtract 1, and we can distribute that 3. So we're going to get 6 C minus 2 equals 24. Divide both sides by 6. Square both sides. Add 2. So if C were equal to 18, then F of G of 18 should equal 25. So let's just double check that that is true. So F of G of 18, we think, should equal 25. So G of 18, if I plug in 18 to the G function, we'll get square root of 16, which is 4, times 2, which is 8. So F of 8, does that give us 25? Well, 3 times 8 is 24, plus 1 is 25, so 25 equals 25, so check. So 18 is the correct C value that will produce 25 as an output with the composition of F or G into F. So that's how you're going to handle compositions evaluated as specific input. You work inside out. So here's your input, evaluate it first at the inner function, then at the outer function. And we only dealt with 2 layers here, but again, there could theoretically be as many layers as we want, so just peel them back one by one. Now let's work with function composition with just the function expressions themselves and the no input value. So for part A, we want to figure out what is the new function that results from a composition of G into F. So F of G of X is asking us to find what is the result when I take this function G, the square root of X, and plug it in to F. So there's a couple ways you can format this if it's difficult to see what should be the result. You can say, well, I know G is radical F, so I have to evaluate F at, radical X. So if I have to evaluate F at square root of X, I'm just going to replace all the X's with square root of X. So you can see that instead of X, we've replaced them with the expression for G. Then you could simplify this, taking this, if you square root, it goes away. The other thing we can't do anything with. So that would be the function that is the result of composing G into F. Now, if we backtrack, another way you could approach it, that'll get us the same result, is you could take F, and then instead of X, we got to plug in G. So I'm going to write G of X squared minus G of X. So what is G of X? Well, we know it's square root of X. And you'll see we get the same thing. So you can compose with the actual function notation in the expression and then replace that function notation with the equivalent algebraic expression that is given to you and then work from there. So that's another alternative route that we can do to get our final answer. So we know the first one is X minus square root of X. The next one, G of F of X. So F of X is X squared minus X. So I have to plug in X squared minus X to G of X. So it's going to be square root, and then instead of X, we're going to replace that with the function f. We can't simplify that any further, so there's our answer. F of x means evaluate f at itself. So using the alternative notation, wherever I have that x value, that input variable in f, I'm going to replace that with function notation f of x. But what is f of x? We know it's x squared minus x. By the way, whenever you input an expression that represents the function into another function, put parentheses around it, especially if there are multiple terms to that expression. Now we could clean this up because it looks like terms will be had if we expand this quadratic. So expanding that out, we're going to get x to the fourth minus 2x cubed plus x squared minus x squared plus x. The x squareds cancel out, and our final result, a single string polynomial with combined like terms, that is a result of composing f into itself. So f of x is this polynomial. And then for the last one, what's g of x? So we know g of x, so again, I'll use a different notation. G of x is square root of x, so I'm plugging square root of x into itself. So instead of x, I'm going to replace it with this new input. So we have square root of x, or square root of x. And that is g composed with itself. So there is a video on function composition at specific input values that we did on the previous slide and with functions.